All right. Good morning or good afternoon, everyone. My name is Andrew Sartorelli. I'm the product manager here at nTopology for nTop platform, and I'm excited to get a chance today to talk to you a bit about some of the new features we've released in nTop platform 2.18, which went out kind of early September timeframe. And one of the things that has me most excited about this release is our ability to work better with other simulation tools. So in this case today, I'm going to talk to you a bit about how you can do some amazing stuff inside nTop platform, send your models off to Ansys Mechanical, analyze the part there, and then take your results back into nTop platform and use them just like you would use simulation results that you've generated natively inside nTop platform. We're then going to get into some enhancements to our random points algorithm to allow you to really structure foam-like materials in a more organized manner. And I'm going to get into a little bit of a more technical feature we've added for filtering, which sounds a little bit boring, I gotta admit, but it's actually really exciting and unlocks a lot of, I think, new capabilities for folks to really architect their designs in exactly the way that they want. All right, so the first model I'm going to start out with here, you're probably pretty familiar with it if you've seen some of our nTop lives. It's this automotive bracket put together by my colleague, Jonathan Harris. And so in this case, you know, we went ahead, we did our smoothing. That's just absolutely amazing, and we've come out with this final part. And I did this analysis afterwards of the topology optimized part inside nTop platform. If you've seen this before, you know the next step is going to be we're going to do some stress-based removing of material stress-based hollowing of this part. But actually, I'm gonna take a step back, and what I'm going to do is I'm actually going to export my analysis to Ansys Mechanical. And so the way we do that, if we go up to simulation, we're going to take a look here, and there's an exchange option. We're going to go ahead and do export static analysis and just take a look at that block here. And it takes a few different inputs. So path, that's pretty straightforward. A path where we're going to save out this file to, our model, our boundary conditions. And then because we are exporting out to another FEA tool, we do need to make sure to specify our unit system, which is always important when working with these input decks for other tools. So I've already gone ahead and done that here. You can see it already filled out with the model that I had used for my static analysis. And if I'd already set up that model to analyze, like I've done here, I could actually just go ahead and start doing a control drag and drag these down, the model and the load cases, into the appropriate input fields. In this case, I exported out a CDB file. And this is a Ansys Mechanical ADPL file that I can actually read directly into Ansys Mechanical. Now, the way to do that, you're just going to go ahead and drag and drop that CDB file into your instance of Ansys Mechanical. It's actually going to do all the work for you in terms of Workbench. So in this case, if I open up Ansys Workbench, I can see it's already gone in and set up the external model block, mechanical model block, and then as I created my static structural analysis in Ansys Mechanical, I went ahead and created that block for me. And so you can see here I've got some results inside Ansys. We've got some stress as well as deformation displacement results. Now, previously, if you wanted to get these results back into nTop platform, you'd have to go through and export a CSV file, but we really streamlined the process now. And what you can do is actually directly read in that Ansys result file. In this case, it's going to be an RST file. And so let's jump back to nTop platform and take a look at that. So we have a new block that we've introduced, again, with the latest release here. And you're going to find that under our beta blocks. And so if we click on beta, if you look at analysis exchange, you actually see 3 different options here, or excuse me, 4 different options: import static, thermal, modal, or buckling analysis results. In this case, we did just a static analysis, so we can go back and we're going to use the import static analysis. It takes a path, in this case, a path to your RST file and your unit system again. And that's all you need to do. And it's going to go ahead and create, look here, a native nTop kind of analysis object that we're going to be able to use throughout the process, just like we would for any other results. And so again, this is all coming in, reading directly from Ansys. And what I've done is I've done the same stress-based modifiers that we used previously. And what I can do is simply generate a point map of my results and start using that information, discretized form, start modifying my geometry. And so if I go down here and just take a look at my variable shelled object, I can see that same stress-based shelling operation that we did before, previously with nTop results, now done with Ansys results as well. So you really have the full flexibility to use what simulation tools you want to drive your design process inside nTop platform. Now, so one of the next things I want to talk about here, we have this ability to import results, and I mentioned we have this really interesting filter block, and so we're going to just jump back to my display point map here that shows my results. And now with the point map, we can kind of filter our lower bounds and upper bounds to isolate some points. And it's great for visualization, but what if you actually wanted to extract those points? Well, previously it wasn't possible, but now we've introduced this block. It's called filter. So you're going to go under utilities, and you'll see it under the general panel. If I click the drop down here, you can see the last option as well as the filter icon there will generate this filter block. And it takes two things. It takes a list, and then it takes a Boolean list, a true or false evaluation for each object there. And so in this case, I've got my stress results, right? And maybe I want to figure out which points have a stress value greater than a certain threshold. So what I would do is I would go ahead and create a filter block. For the list of objects I'm going to filter, well, I'm going to look at my point map, and I'm just going to drag out my list of points here. So that's the first object. And then I'm going to go ahead and I'm going to use stress. So I'm going to start typing greater than or equal to. And let's drag this just right below there. And I'm going to change my overload to scalar. And what do I want to say? I want to see all my points that are above 2.28, let's say E5 pascals. That's going to be the lower option. And what I'm going to do for the other option, I'm just going to go back into my properties. I'm going to pull out my values. All right, so those values correspond to each point. And now we're going to get this evaluation occurring of which values are greater than our 2.28 E5 value. So I've already gone ahead and done that with one of the sets here. So I'm going to go ahead and delete this just to speed up the process a little bit. And let's take a look. So now I can see I have that set of points only above that value. You could also go ahead and do the same filtering operation and select only the values above that and recreate a point map here. And so now I have a point map that consists only of points with a stress value greater than the value that I've specified. A lot of different applications for this, allowing you to create your own custom blocks to do things like filtering points within a volume. So you want to isolate just a few points. All of that is now possible with this filter operation. Okay, I'm going to jump over to another model here that I've got set up. And this is a model I think I've shown previously, which is a kind of a seat cushion model that we've grabbed here with a couple different lattice structures. So if I look at the kind of middle face back here, we can see this is a more randomized Voronoi structure. But a lot of folks have asked about creating a more structured kind of foam-like material here. Maybe that's conforming to your object more so than a traditional lattice structure would. And so above here, you can see that the outcome I've created here with these more structured points. So let's talk a bit about how you get to that process. So I've already gone ahead and I've isolated my kind of head back cushion here. And the first step in this process is it's going to require a volume mesh. So I've already gone ahead and gone for my surface mesh. I'm just going to use the volume mesh block. We're not caring too much about the discretization here. It just needs to be a volume mesh. And then the block I can use is called random points in volume mesh. Like the previous blocks I mentioned, it's falling on the beta tab. So you can go here, beta, modeling utilities, and you can find the random points in volume mesh. Of course, like any of our blocks, you can always use the search dialog here. And so all you have to do, drag in your volume mesh to the first entry, specify the number of points. It's going to go through and use relaxation iterations to normalize that spacing. And so now if I just press I to isolate, you can see not a whole lot of points there. So maybe let's increase that so we get more points within our volume. Maybe let's do 400 points. Right. And it's going to go through the same process. It's going to try to control the spacing between all of these points to end up with a more regular distribution. So here we can see that more normalized distribution between all of our points. And what we're going to do is we're going to use our Voronoi volume lattice to generate this foam-like structure. So I'm going to use some of the new blocks from our new lattice pipeline, and I'm going to go under beta, lattices generate, and I'm going to take the Voronoi volume lattice body. It's going to take my seed points. It's going to take a thickness. In this case, let's see, I'm probably going to want a thickness maybe of, let's go with 4 millimeters. And now it's going to go ahead and generate that more uniform lattice structure between my object here. Now, obviously, it's not ideal with some of these points sticking out. And so let's take a step through and look at what I did for the head seat that I've already prepared, come up with a nice kind of conformal foam-like structure for this cushion. So we'll go ahead and delete my body there and my body there, and let's step into our head cushion. So this is the one I'd come up with before. And so what we did is we did that Voronoi volume lattice along the interior. We trimmed it to a mesh in this instance, but I also wanted a nice little kind of ribbing around the exterior as well. So I used one of the surface lattice options, and I used the surface boundary to select that edge. And I just joined those two structures together. And so now you end up with this nice uniform foam-like structure. It conforms very nicely to our original design space. Now, the interesting thing here is, just like our other objects, if we take a look at some of the other cushions I had gone ahead and created here, let's take a look at the bottom cushion. They actually have the ability to control the spacing as well, controlling the distribution. So in this instance, I just ramped the spacing from the edge of my object, but you can imagine, right, this is a car seat. Maybe I want to use a pressure map or something along those lines to drive my distribution. And certainly all of that is possible within nTop platform. All right, so hopefully everyone learned a little bit today about some of the new features that we have in the latest release of nTop platform 2.18. Right, this includes the ability to read in results from third-party FEA tools. Right now, that's Ansys Mechanical as well as Nastran. So that's coming through from Ansys Mechanical with the RST or RTH format, and with Nastran, that's the OP2 format. And we're supporting reading in linear static analyses, buckling, modal, steady-state thermal, as well as transient thermal analyses. Now, if you have some other analysis types that you'd really like to get the data in from another tool into nTop platform, be sure to let us know. We're always looking to enhance our capabilities there to enable you to create parts that you simply can't create anywhere else. And the other features we talked about, right, the filter block, allowing you to really have that control and selection over different objects within nTop platform. You saw me use that to select points from a point map. Certainly a lot of other options are going to be available. You should see some interesting new custom blocks come from us at nTopology. Allow control of lattice structures, selecting specific beams from structures. And the final topic we had today was this random points in a volume mesh, allowing you greater control over these foam-like structures to allow you to conform those to unique geometries. Hope everyone has a great rest of their day and learned a bit today. Thanks a lot and take care.